Hi everyone, hope you are having a great evening. And first of all, I know it's the mid of a week, and especially at the 7th. So thank you all for joining in. Without further ado, let's get started. So let me know when my screen is visible. Awesome, thanks. So today we'll be having a walkthrough on what is basically DevPod and what Keploy does, how you can build and collaborate with your fellow teammates if you're building up side projects or going in a hackathon or working on some specific features, how to build those and test them. But before that, something about me. So, hi, I am Animesh. I work at Keploy as a DevRel engineer. I am a random community guy, to be honest. Been working in a community with the community for at least last couple of years, 2 to 3 years. It has been. I'm also one of the gold MLSAs and CNCF Noida organizers. So before that, does anyone have any thought on how generally a software lifecycle looks like? Okay, so traditionally of how it works, it can be explained in a simple thing. The project they want me to run on it, it works on my machine, which is on my office laptop, and no one is able to replicate it on anyone else. So that is one of the main things that generally happens between software developers or when we are collaborating with folks. Gotcha. So this is how generally the things work, the flow works like. And it is seen in very commonly when we are talking about how the things are going to work. So for example, if it's a feature implementation, I have implemented a feature. Now, if I give it to someone else, maybe a QA as that, and they don't have any setup prior, like environment setup, production setup, whatever environment they are needed to require that specific feature or program, then they are going to come up and say, oh hey, this is not working as expected, and then send back. So there's a lot of through to and forth back. So I'm not saying like it cannot be replicated. That's what I'm saying. Generally, the replication becomes hard because if something is working on my machine, if it's not an isolated or a container sort of thing, or especially in a case of Docker, until unless it's a Docker, you're running everything on natively. There could be environment variables that are hampering the workflow, but it is working fine. And if someone follows the same step, but it is working for them, but it's not working for you. So that's what I'm talking about. In that scenario, it gets very tough to replicate, especially if you go on a client calls. In certain scenarios, you may even not be able to replicate until it's in the pipeline. So that's what I meant. So this is the general workflow. Like it's generally a sprint looks like. If I take an example of developers or a QA as that, or automation test engineers. So how it works in a month, if I take a sprint of a month long, then generally a 1.5 weeks is taken by to develop that feature, and the rest, at least half a week, goes into testing that feature by the developer itself, right? To check whether okay, it is working perfectly fine on my machine. Now, then it goes back to the QAs or SDETs or whoever does the final testing before the production. Generally, those are SDETs and QAs. So again, it requires them at least bare minimum 2 weeks with a lot of to and fro back with the developers, because how it works, they have certain tests, right? So they already have prepared some tests and they check whether the new things are working fine with the existing ones or not. So till the developer has started, made some commits, check, verifies everything, then makes a commit, final commit. Then it goes to the QA. They test the like setups the environment, check or maintain the previous written test, unit test. It could be unit test, integration, A to A, and such. And once they have done with the flow, then it goes to into production after they sign it off. So a complete this whole thing takes around 100% effort and a complete week. And to be honest, it takes actually more than a month. In a month-long sprint, in a 4-week sprint, it generally gets extended to 6 to 7 weeks, which is definitely a bigger issue for the companies, because even if the feature is live, it's not required anymore. The marketing has been, when I say that, what I mean is the marketing has not been done, or it has prolonged it for a very long period of time. Now, either the audience has, or the target audience has the interest and they're waiting for that release, or they have already lost the interest and they have failed to capture the market. In the meanwhile, since it's a very competitive world, a rival company or a rival group or a team, like cross function team, not to be precise, but a rival company could have launched the same thing before them and have trademarked it. So these are the limitations that we generally don't see from outside, like how this has impacted us. But the marketing gap has occurred, the price has went up, while development and testing, the time to actually test everything and make sure that it is working fine across all the dependencies that one could have, it's not. It has been released in a hassle. So these are the some limitations. One of the popular examples, if I take of the recent things, while the development and the testing part, most of us are very familiar with GitHub issue when it went down, GitHub code spaces. Second was Slack when they were testing it. In a COVID period, Zoom meetings used to suddenly end randomly, used to end, or people were unable to join. And if I talk about very recently, LinkedIn and Twitter went, Instagram went down, to be precise here, couple of weeks back. Yeah, a couple of weeks back when Instagram went down, no one noticed. Like people were trying to refresh it and thinking that they have a slow internet connection, and later after 8 to 12 hours it got fixed, and then people realized, okay, it was not just my issue, everyone was facing the same, and meanwhile they were talking and doing other stuff. So these are the popular examples where that implemented features were not like cleared perfectly. They had some issues, but still were released because there were not enough time to market it. When and it is all the releases are generally done at the last moment, to be honest, and that's how our software lifecycle actually moves ahead. So now there are a couple of solutions, as I talked at the starting, in a replication, when I was addressing the replication issue. One of the best is to use Docker images and Docker containers, since it has everything packed inside. If I share the same, create a Docker image and share it with anyone over the globe, they'll be able to replicate the same thing, same steps with same environment. Similarly, there's a concept of called dev containers. Now, how to use dev containers and what are those? So if you look at the architecture, dev containers, there are three types of places. The inner loop needs, what inner loop actually is, how it works, right? So in inner loop, we have our compilers, SDK. So these are the things that we create our applications, like our local systems. We have debuggers, OS utilities, CLI, different personalized productivity tools such as ZSH, autocomplete, syntax highlighting, compilers, SDKs, and such, right? But as soon as we move it to the CI, that's the outer loop, we only get our OS runtime libraries and some compilers and build tools. That's all. And after that, it comes a production container in which we have nothing, just the compiled application. That is where our deployed apps are. Now, when so this is a general thing that dev containers, or generally how we use a Docker image or Docker containers. That's where the DevPod comes in. So couple of things. If anyone has any questions, they can comment. They can ask in the comments and chats. Take a pause and then we'll start a minute or so. Okay, I think no questions yet. Good. So yeah, we were talking about DevPods. So DevPod is something similar to JetBrains, GitHub code spaces, and how we generally think, how we generally uses Gitpods and such stuff. But the thing is, it's open source and client only. So you install it and it runs. It creates a VM on your own local machine, and then you can start using it. That's one of the best benefits of DevPod. How it works? So basically, there's a dev container, right? There's a dev container. So basically, you can think of DevPod as a glue that connects your local ID to the machine. Basically, it spin up the Docker container and then gives you a complete access, privileged access, agents and such sorts by while using SSH. So when you do SSH and log get started with the DevPod, um, you get certain things like port forwarding, that there's already the dev pod agent. And the interesting thing is you get the dev container.json. Now, why that is interesting? Because with that, you can actually use the same repository or same code base across everything. If you can upload it to a code spaces, create, or basically it has a kind of instructions on how to run things. So that's one of the best things with the depot. It gets created automatically. It will have your configs. So what images you are using, what kind of container you have, whether it's privileged or not. If it isn't, you can add more lines on it. You can add your own agents and things. And the plus point is, I think I have it in. So if you can see on the right side, you will see multiple languages and local IDs. So these are the default ID. For example, if you like to use VS Code, you have VS Code, inbuilt, JetBrains, PyCharm, Rust Rover. So whatever language you are using, you get fully supported JetBrains and VS Codes over the SSH. Plus, since it's an open source, so if you think here you need any additional local IDs, or you want to add your local ID, preferred IDs, or the language or the providers, you can add. So just take a pull and commit to it. And similarly, it's like a similar to desktop, Docker desktop, right? So you open it, you get your dashboard, you can create workspaces, you can create volumes, images, providers, select, and do multiple stuff. So we'll have a walkthrough of that. Okay. So far, anyone has any questions? Good. Then let's move on to how to test your application. Now, once we have our application up and running, so we could have um, a simple sample Go app in which we are doing a CRUD calls, creating maybe post, user, and then maybe recipes, comment, and such stuff. How to test it? One popular way is to use Postman. Now, the problem with the Postman is it's just a API testing platform rather than a complete testing platform. Why I say so? Because you can write your scripts, you can test those scripts, you can run how the functionality of the API is working based on request and response. But that's it you can do with those request and response. If you have to create a mock data, then you have to first make sure that the mock data is perfect while you create it. So that's one way to use Postman or Hopscotch. Now, like if I talk about Keploy, how Keploy was different. So Keploy basically uses an eBPF agent similar to New Relic and Cilium or Solo.io, but I think it's Bumblebee. So that's like similar to that. Keploy has a eBPF agent. Now, what eBPF does? It basically listens to all the OS and network calls that are happening on your kernel level. Everything that we do, even opening the desktop app, Chrome, or making some opening the web browser, searching something, all those are happening. Or if it's on our machine, then it's all happening, there are processes attached to it with on our local machine. So eBPF is a tool that helps in listening those, filtering and modifying that. Kepler uses eBPF agent to basically listen to those system calls, get the request, response, what was the actual response, status code, and capture those, and then makes a certain system calls to modify that, so it acts as a so that it will be able to act as a transparent proxy. Now, when I say a transparent proxy, what I mean is, if there is a server, let's assume server A sends a request to client B, the Keploy will act as a proxy, and the client A would think that it's actually talking to the, like server A would be thinking that it's actually talking to the client B, and a vice versa. So no matter like how your app is running, it won't hamper anything. Like it won't interfere with the application. Rather, just sit there and listen. Now, after it has listened, it has captured those request calls. It will convert them into test cases and data mocks. So the test cases would be generated on the incoming responses, and the data mocks would be generated on the basis of output responses. So similar to like how I said, you're making some curl request API request. Now you can actually see like what were the difference and why it failed, or like if I expected XYZ in a body, now I'm getting ABC or error or invalid token maybe, and why this is happening, what went wrong in my application. So if I talk about microservices and monoliths, there are multiple in the terms of microservices, there are multiple APIs that are talking to each other on a very frequent basis, right? And they are dependent on each other. So if one fails, there's a chance the second could fail as well. And to avoid those and work with those, it's that's where deploy comes in. So I'll just show off how it works. Let me know if my screen becomes visible. There's the issue with screen sharing. Just a minute. Yep, it's like, so let me go to VS Code first. Yeah. So I'll start my dev pods. Similar to desktop, Docker desktop, as I mentioned, we have a tool, like a desktop tool called dev pods. I'll just remove this. Yeah. So there are multiple ways. Since I am using Docker agent, I have a provider called Docker. You can choose SSH, Kubernetes directly to Kubernetes clusters, AWS, Azure, DigitalOcean, Civo, and community plus custom means you can create your own or configure your own personal providers. So I have it up and installed. Yep, it's running now. So this is a command. I'll explain what it means. So this is my repository. For example, so the general format is my GitHub repo, owner and repo name, and the pre-built repository. It means I have already made the Docker container and Docker image of my application. And now what I'll do, I'll just do DevPod up my repo code base and pre-built repository with this. So how it works, it's creating a Docker, creating the dev container that I already had in my image. Now it sets up and creates. So I generally have VS Code on me. I am not a very frequent JetBrains user. So so it has downloaded the VS Code server. It's initializing it as well as loading the things. Now, if anyone has a DevPod in their system or in a lab on their machine, if I just share the previous command with them, if I just share this thing, the details of my image and this, they'll be able to replicate it step by step of what things there are, how it works, with all the environment variables, SQLs, git ignore, my already created folders, dev container. So as I mentioned, dev container looks something like this. And so this is a Go exam, Go based project. That's why I have Go 1.21, and this are my feature images with run with privilege and no add. Reason being because Keploy needs sudo access. Since we will see how it captures all time.
Hi, Animesh.
Yeah.
Yeah, could you please present it? Uh, I guess the screen is not being presented.
Okay. Um, okay. Is it visible now?
Yes, it is visible now.
So, okay, I think I'll go a few steps back. DevPod, I'll create this cluster. So this will be deleted. Yeah. So if I have my own repo, I can open my repo and then create an image and then move ahead or with the folder if where I want to open it. Similarly, if I have by default chosen VS Code, that because that's preferred for me. Otherwise, and Docker as well. So if you're working on Azure, DigitalOcean, CVO, AWS, or G Cloud, you can select those as a provider and do direct SSH into them. So for this, I have Docker up and running with one workspace, and this is how it looks. So this thing that pre-built repository means that everything that I have in this image, like Sonichigo slash devpod hyphen deploy, will be created. Every thing will be created on the basis of this repository in a new container, and that's a dev container, like my development container. So once the cloning has done, I'll show you of how the JSON and if we configure our dev container JSON of how it would look. I'll also open this one for the comparison. So both are the small projects. So I got all my Go vendors and everything with. So this has 1.9. This one has 1.21. So all I needed was to do. So there are two ways, as I mentioned. Workspace create. Either I give GitHub repository directly and then move on creating with commits, pull requests, and subfolders, and then edit on those. This is very helpful if we are working parallelly on a feature release. So most of the open source companies and the projects, they have something called main branch, dev branch, and release branch. If I take an example of Go itself, so it maintains the last two stable versions. So if you go on a Go, the latest would be the dev, that's 1.23, and it will maintain the history till the last two. So those are 22 and 21. Before that, you won't be able to find much. So similarly, with each small commits and things, I can create my own. I don't have to make a PR or commit to it. So this, what I meant was, since this is pretty basic one, I don't have any Git repository. All I needed was a project like Git, GHDR, and my container name. So with this, I was able to set up everything in the same manner with the environment tests that were present. App.go, with I even have my coverage here with the Docker Compose and such stuff. So let me go and build this. Okay, I may need to install third-party apps. Mm, Meanwhile, it's loading. Does anyone have any questions? Cool, let me know. Yep, I think it's installed. Alpha 15 it is. So let me drag it up a bit more. So if I go and get started with this, how it will work. So it works in a similar way a get works. So Keploy is a get message, get command. Record is a commit message with some flags. In this case, it would be go run.go. But before that, let me build this. Okay, build BSC false at build BCC false to oh, God. Yep. So I got my binary. Now let's use this binary to see of how the things actually work. Dot slash test app product catalog, and I would need to bring up my database as well. So let's see if I can bring it up. Yep, it's available here. So using Docker Composer, and it's pretty much so these things you can think of it as Docker in Docker. We have a Docker, and which so the whole code spaces or the or since I am using a Docker provider, it has given me a Docker container in which I'm running my everything, and in Docker container I'll be running my new containers and such. So okay, create network, create Keploy network. Yeah, I think now it should be printed. Yep. So let's check the status. If it's working, my database is up. Now let's bring my application. Okay, so my application is up and running as well. Now, if I make some certain wrong calls before I move to the correct ones, let's see what I would get. So from here, let's remove this and copy paste the same thing. Let's create a new terminal, fresh terminal. So I got ID name is empty, price 123. Now let's make with one this bubbles price 123 and make some calls on get. Yep, so now I got an empty response, which should not have happened because I already have a response. Let's go and make a query to the first product. I got it. Second product, I got it. So I know something is not working with my dash slash products. That's that API. Now let's see. If I go and start yep, so now we can see it actually got an error and it failed. Reason being, if I just have made API calls I would see, okay, the response is 200, it's working fine, but that's not actually the case. I need my the expected headers are different, the content lengths are different, the actual status, the expected and actual bodies are very different. So that's why these things become a bit crucial to check of how the things are working when we go into CI/CD or pipelines and we talk about deployment. Okay, so pulling down. Okay, so this was a very short demo on how this works. If you want to use or create a build with DevPods with the same setup, so now if I have installed Keploy, if anyone else does the same command and run it, they'll have the Keploy or the other CLIs. If I add the ZHS as well, they'll have those things when they pull in and bring it up. So the multi steps. Let me have a walk through with that. So developing pre-build a workspace. Yep. So similar to how we do Docker build, dash D and such, it has devpod build, my repo name, and similarly the access to GHCR. So if I run this thing, it will create a container of my repository and put my repository in that and will upload it. So whenever someone calls it with again with devpod, it will decrypt it and make it file life sized back again. So that's it. I think. Yep. So that's all, folks, for this session. Hope you enjoyed it. You can so there's a giveaway. We have a T-shirt giveaway for best social post on Twitter and LinkedIn both. So share about the sessions, your learnings, what you got to learn about, and tag Keploy, tag um, GSSOC, and tag me. So these are the steps, and do mark star Keploy. So it's very simple. If you go and then you go, it's just a simple star mark that you can do. So these are the three steps that you have to follow, and do scan, make like scan the QR, so and fill the form. That's a feedback form, so that's the third and most final most important steps. So hope you enjoyed, you got to learn something new, and hope this was an interesting experience for you. So if anyone has any questions, I'm open to answering those. Okay. Hope you had a great time, and thanks for joining it. And it's a bit late evening, and still you guys are here. So thanks a lot.